inverted.
Can I say, Trisha, you were saying something, Bolo?
Basically, when an image is reflected, I'm not so sure how to.
Image is reflected. So can I use the word bouncing back? So the light falls on an object and bounces back, then I call it as reflection, right?
Yeah.
Right? That is reflection. It happens in sound also, it happens in light also, right? So light is falling on these buildings and it is bouncing back, and an image is being created in a polished surface, in a very smooth surface, okay? So first, now we are going to talk straight away, come to the main point, which is laws of reflection. So, you know what is angle of incidence? So there is a mirror that you see. This is a plane mirror. What kind of mirror is it? It's a plane mirror. On that mirror, there's a normal. Normal is always a line which is perpendicular to the mirror. Normal is always at an angle of 90 degree to the mirror. Clear? So there is this normal on the mirror. Then you see that the angle of incidence. So there's an incident ray. First, do you see that incident ray, which is falling on the mirror at the same point where the normal is? Now there is an angle which is being made between that incident ray and the normal. Now, a lot of children make a mistake. They say this angle. This is wrong. It has to be the angle from the normal, that angle. Okay, that's the right one. So you figure out the incident ray, you find the angle from the normal to the incident ray, and then that light will fall on the mirror and be reflected. It will bounce back. That ray of light will bounce back, right?
Yeah.
Again, it will form an angle with the normal, and that will be called as angle of reflection. And what is the law of reflection? It says that both angles are always equal. What is the law of reflection? Angle I is equal to angle R. Angle of incidence is equal to angle of reflection. Clear?
Yes.
Right? All right. After that, there's one more point. That all the three, which is the incident ray, the normal, and the reflected ray, they should be in the same plane. So one is angle I is equal to angle R, and second is incident ray, reflected ray, and normal are in the same plane. So this is your law of reflection. Clear? Something we have heard about in grade 7 and 8 also. We are aware of what this whole thing is about. Okay. Now, one common mistake, what children do? So the teacher will give you this angle. And she will ask you, find out the angle of reflection. Children will not look at it and straight away write this as 30 degree. Is that the right answer?
No.
60.
It should be 60 degree. Reason?
So
It adds
basically,
up to 90 degrees.
Yes. So what is the incident ray angle?
so that angle plus angle of incidence is 90. So 90 minus 30 is angle of incidence. So that's 60. And angle of incidence is equal to angle of reflection. So 60.
Excellent. So this has to be 60. So we are clear on this, right?
Yeah.
Very good. All right. Now this is done. Yeah. Okay. These are the image which is, this is the property of the image which is being formed by a plane mirror. तो पहले हम इसको बनाना सीखते हैं, ठीक है? When you're making this, do you have your notebooks with you?
Yeah.
So you are going to draw with me. Make a plane mirror. Make a plane mirror. This is your plane mirror. You use a scale and a pencil. Clear? Plane mirror banaya? Make this object. Made?
1 second. Yeah.
Object ban gaya? Is it done?
1 second.
After these two are done, make a ray like this from the object to the plane mirror. And make a normal. Make a normal and make the ray like this. So the one which is coming towards the mirror is the incident ray, and the one which is being reflected back is the reflected ray.
Done.
Done? Reflected ray drawn?
Yeah.
Now make one more from there. So that L will have many rays coming from it. All right. We are only taking 2 of them. We don't take many. We'll only take 2 of them. So again, another incident ray. On that point where the incident ray is, there is another normal and the reflected ray. So 2 of these incident, 2 normals, 2 reflected rays, right? Done? Now produce both these lines backwards, behind the mirror. Use a scale. They will automatically intersect at a place, at a point.
Make a straight line, right?
Behind the mirror. Both the reflected rays have to be produced back. Done?
Yeah.
Yeah.
So now see the kind of ray which is being formed. So this is the point. This was your point. This was the point. That point is being formed here. And the image is laterally inverted. Okay? Right? So now we are going to talk about the properties. The properties are, do you see the object is of the same size as the, image is as the same size of as the object. The distance from the mirror, this distance of the object and the image is the same. Both the object was erect and the image is also upright. It's erect, same way as the object, but the image is laterally inverted. The left becomes right and the right becomes left. So these are the properties of a plane mirror. Whenever you get an image in a plane mirror, this is something that you see. When you also stand in front of the plane mirror, what do you see? You see your image, same size as you, same distance as you from the mirror. The image is also at the same distance. It's also upright, just that the left becomes right and the right becomes left. Enough? If you see the word mirror, I'll write the word mirror here. Let me write mirror. If this is what you write in front and you stand in front of a mirror, you will get that's how you will see it. That's called lateral inversion. Okay. Now in this image, one very important thing that we saw was, were these lines, when you extend this further, will they ever intersect? No. Why? Because the gap between them is increasing and increasing and increasing. They will never intersect. So what we see is there is no actual intersection of the reflected rays. The reflected rays are not intersecting. They are not intersecting actually. Right? So what we had to do, we had to produce them back. And whenever we produce these lines back, we always show them by dotted lines, right? So you made them, you produced them and you made them intersect on the other side. Such images will always be called as virtual image because they can't be, first, they are not formed by actual intersection of reflected rays. And second, they're not formed by actual intersection of reflected rays. And second, they can't be produced on a screen. Can't be produced on a screen. What do I mean by that? One, you understood that they are not actually intersecting. You had to produce them back to make them intersect. Right? That is one point. Second point is they can't be produced on a screen. Iska matlab hua, have you ever gone to a movie theater? Movie theater? Shamik, concentrate on the screen. Have you ever gone to a movie theater? What do you watch the movie on?
A screen.
A screen. So there is something which is being reflected on the screen. So all the image which is there is being produced on the screen, which you can't do with the plane mirror. You cannot produce yourself on a screen if you have a mirror like this. Understood? Clear? Leave your phone, Shamik.
I'm not using it.
Then what are you looking at?
Screen.
Huh? Where is the screen? Below?
My laptop like this.
Come closer to the laptop first. So this part is clear. What is a virtual image? Real image will be always when there's actual intersection of the lines and the object can be produced on the image can be produced on the screen. Virtual images are the lines you have to produce, you have to, bring it backwards, you have to make them intersect. So you show them by dotted lines, and second, they cannot be produced on a screen. Clear? Right? Risha, samajh aaya?
Yes.
Chalo. Questions now. So Shamik, read the first line, answer, then stop. Trisha, you will read the second line, then answer. That's how you will be doing it.
Should I answer?
Now start karo. Read the statement.
The law of reflection states that the angle of incidence is always equal to the angle of reflection is always equal to the angle of incidence.
Reflection is always equal to. Okay, Trisha.
Both angles are measured relative to the normal.
Okay.
That is 90 degrees to the reflecting surface at a point of reflection.
Okay. Shamik.
A plane mirror forms a virtual image which is unlike a real image in it that it cannot be cast onto a screen. The image in a plane mirror is also the same size and the same way up as the object.
Perfect. Okay. That was reflection. Now what is this?
Change in medium, so refraction.
This is refraction. What is the difference between reflection and refraction?
Reflection is when there is no change in medium and the rays of light are straight.
Rays of light are straight. Or there's no change in medium, or?
And the speed of light is constant.
Okay. What else?
And the image is and the ray is not bending.
Why is the ray bending here?
Because of the change in medium.
Why is the medium changing? Why is it not remaining in the same medium?
Why? मतलब अभी इस पे प्रोजेक्ट किया तो चेंज हो रहा है.
क्यों प्रोजेक्ट क्यों इसमें क्यों चेंज हो रहा है वहां क्यों चेंज नहीं हुआ?
Because the medium is constant, so the particle that has to go through and pass through is the same.
So in that case, the object was opaque. In this case, the object is either transparent or translucent. So the light is passing through it. Got it?
Mm.
Got it? So the thing was there, the object is playing the role. Object was there was an opaque object. So the light fell on it and bounced back. क्योंकि उसको जगह नहीं मिली आगे जाने की.
Yeah. Huh.
Got it?
In terms of the mirror.
Huh?
In terms of the mirror.
In terms of mirror, in terms of the buildings, in terms of anything, in terms of anything, any opaque object. Refraction तभी होगा जब हमारा object opaque, either it is a transparent medium, transparent object or a translucent object, जिसके through light pass कर सके, तभी refraction होगा, right? Trisha, right? Right?
Yeah.
Okay. Now tell me, you have I can see there's a window behind you, right? Both of you, beside you. So will the light pass through it?
Yes.
Does the light pass through it? Yes, because it is a transparent medium, right? Ab kya hoga? When the light is passing through, all right? So let's take an example. This is your window. यहाँ पर क्या है? Air है. इधर बाहर window के बाहर भी air है. But when it is inside this, when I'm talking about this glass, here this is glass.
Yeah.
So the light is coming. जब तक ये air में था तब तक वो ठीक चल रहा था. जैसे यहाँ आया तो bend हो गया. Because it is changing. You said earlier that it is changing the medium. So from air to glass and then glass to air. So twice it is changing the medium. Right? So at both the places you see a bend. Right? अब इसको हम समझते हैं. Let's understand this using example of a traffic. There's a lot of traffic. So what happens when there is you're running on a highway, you're driving on a highway. So in that case, and there's hardly any traffic. So what will be the speed?
Constant high.
Speed will be higher.
Yeah.
Higher. But जैसे ही आप higher traffic में जाते हो, आप city में आ गए. Okay. Now you're in the city. So in the city, what will happen?
Lesser speed because more.
As the traffic is more, so speed is less.
Yeah.
Then again, you leave the city and you're going somewhere else. So then what will happen? Speed will
Again,
increase.
speed.
So again, it will be higher.
Yeah.
So it's all because of the traffic. All of this happened because of the traffic. Now look at the traffic in terms of air molecules and molecules in different objects. So if it is a gaseous medium, gas medium, like air, how are the molecules placed?
They're spread apart.
Widely.
They're spread apart. So there is less traffic.
Yeah.
Right? So can I say less dense? But the moment you're into the city, yani ki the moment you're into a solid object, how are the molecules arranged?
Tightly packed.
Tightly packed. So they are dense. They're dense.
Yeah.
Again, outside, they are less dense. Right? The same thing happens with water, but water will not be as dense as glass. Right?
Yeah.
So the less dense will be called as rarer.
And
then this will be called as a denser. And then since you're coming back again to the rarer medium, so I'll call it rarer again. Did you understand these three words? Denser, rarer, and this is also rarer. अब आपको मैं एक word देती हूँ. The word is drawn. Drawn. This is just a mnemonic for you to remember. Whenever the light travels from this has, I will elaborate it. So the light is traveling from a denser to a rarer medium. It will move away from the normal. D means denser, to rarer. The light which is traveling will move away from normal. And iska exactly opposite hoga, Shamik, concentrate.
yeah.
If it is going from a rarer to denser medium, it will move towards the normal. ये बहुत important है.
Yeah.
Write it down. Drawn, अगर आप drawn याद रखोगे तो आपको दूसरा वाला अपने आप याद रहेगा. If you remember drawn, you will remember the other part of yourself. ठीक है? So how will the light behave when it is going from a denser to a rarer medium?
Away from normal.
And rarer to a denser medium?
Towards normal.
अब जो हमने सीखा, let's see whether it is correct or not. This is what medium? Rarer, denser, rarer, right? And what did we say? Drawn. Drawn. So I'll make a normal here. This angle and this angle, which is bigger?
Air wala.
This angle is bigger, right? Because it is going from denser to rarer. It is moving away. This is moving away from the normal. Whereas in this case, it's rarer to denser. So in this case, it is going to move towards the normal. Towards the normal. This was away and this is towards the normal. Clear hua?
Yeah.
We'll look at a proper ray diagram now for this. Here. Which one is rarer?
Glass.
Air.
Rarer.
Oh, denser is glass, rarer is air.
Rarer. Right? This is how it is?
Yes.
Denser to rarer, we said away from the normal. Is it moving away?
Yeah.
And rarer to denser gets towards the normal. Is it coming towards?
Yes.
So this is how you are going to draw your diagram. You make a glass box, then you make a normal. The incident ray will be here.
You can calculate now
You can calculate, yeah.
with
The
how,
incident ray.
like how much
This is the
the
formula.
angle.
This is the formula. The incident ray and this angle, then this is the reflected. No, sorry, this is the refracted ray, and then it comes here, goes away, and this is the emergent ray,
What is that?
the one which is emerging, finally, emergent ray.
Okay.
Okay, clear?
Mhm.
Incident, refracted, and emergent. Here we have 3 rays. Okay, then we have 2 normals on both the surfaces. Clear? Okay. Look at the pattern and what do you observe here? What is the observation? Any observations?
Not really.
As the angle of incidence increases, the angle of reflection does too.
And the angle of refraction also. Very good. So what is the angle of refraction when it is at 0 degree, which means the answer, this you get a lot of questions on
0.
this. When it is 0 degree, what is the angle? Is it this one or is it this one?
What?
The 0 degree means what?
Oh, the below upper arrow. Upper going arrow.
Upper going matlab which one?
ऊपर जाने वाला. Point.
जाने वाला दोनों है, कौन सा वाला? I'll name it. 1 or 2?
2.
2. Why 2?
Because it's going straight from one medium to the other.
Because you always measure the angle from the normal.
Normal. Yeah.
और normal से वो 0 है because it is on the normal. So normal and that ray, the angle between them is 0 because that ray is on the normal. Okay. So many children screw up this because they get confused and they think it is this one. It's never this one. Okay. Okay. Then what are we doing? We are trying to increase the angle. So 0 degree, then it is 15 degree, then it is 30 degree, then it is karke, you're increasing the angle, right? And then you see here at 0 degree, is there any deviation?
No.
Any deviation? That's another point to notice. If the angle is the incident ray is like this, it will move out undeviated. This is the only ray which moves out undeviated. The one which is at the normal. Is that clear?
Yeah.
Right? Will you remember this? This is something for you to remember. Clear?
Right.
Okay, this is what I told you. Light bend. So the word was given to you was drawn. So यहाँ पर क्या होगा? Air to glass. What will happen?
Towards the normal.
Towards the normal. Okay, यहाँ पर क्या होगा? Water to air.
Away from normal.
Because you're going from the
denser arrow.
Because the water is denser medium. This is a denser medium and this is a rarer medium. So it'll move away from the normal. Right? Right?
Yes.
Okay, now why pool appears shallow? Have you seen this before?
I think I know why.
Yeah.
Batao.
Because of refraction only the light bends when it enters a pool. So I guess instead of going very deep, it goes like it bends towards the normal. So it
So
looks sharp.
we'll understand this through a ray diagram now. Okay. So this is somebody standing outside and watching this object which is inside the water. So this is maybe the floor of water of the swimming pool. So what happens? Let's watch. This is object, there's an incident ray from the object. From the object, there'll be an incident ray.
Yeah.
Another one, you make two normals, like we've done the L ka thing, right? So now the same thing we're doing for this object. So there will be many rays coming out of it. We are just taking two of them. What will happen to this one? Since you're moving from the denser to a rarer medium, it will move away from the normal.
Yeah.
Away ho gaya ye, right? Okay. Now, the other one, that's also moving away from the normal. As you can see, this is also away from the normal. जबकि ये angle जो था वो कम था, ये angle काफी बड़ा हो गया, right? Both are moving away from the normal. Then the observer. Now, what happens now? Are these lines ever going to intersect?
No.
In that case, what do we do?
As in,
If the lines are not intersecting and I want to create an image of it, then what do I do? Like in the L diagram,
You bring it back.
plane mirror.
you bring, like, yes. So you bring it back. So this is how you produce it back. Which rays? The refracted rays in this case, right? You produce it back. See where are they intersecting?
Oh, right. So it goes straight and at like
At a particular point they intersect. Where is that point? Is it at the same place as the object? No. It's above. And that's what? It's an illusion to our eyes. So we think that the object is above, but our object deeper hota hai. But हमको वो ऊपर दिखाई देता है. It is happening because of this phenomenon. Right? Understood?
Yeah.
Okay. I want you to make this diagram. It's an important one. Draw it. And share your work in the group image of both the ray diagrams. Yeah, Shamik, done? Okay. Trisha, done?
Almost.
So Shamik, do you know what do you need to answer when you're asked this question, why a pool appears shallow?
Because of, well,
How will because of
refraction.
refraction? And then can you explain it with the diagram?
Sure.
Yeah, sorry.
Sure.
Unmute yourself. Keep yourself unmuted. Yeah.
So there's an object at the bottom of a pool of water, and there's air above it. So light rays from, I guess, the object travel to the top of the water and then change medium and travel into air. So they bend and refract away
How
from
do
the normal.
they move away from the normal or towards the
Away,
normal?
because
Always mention that. They are moving
from when you're moving from a denser to a rarer medium, you move away from the normal. So here water is denser and air is rarer. So we're moving away from the normal. So both the lines are not intersecting. So when you trace them back and create a virtual lines backwards, and you find out that the image being formed in the water is a lot higher than the actual placement of the object.
right,
So
and
it seems shallower.
and that's what the observer sees.
Yeah, that's a virtual image being created.
And that's the illusion effect that is created, that the object is not at the bottom, it's little above. So it's it's not that deep, it's very shallow.
The bending of light, yeah.
Yes, and this is all happening because of the phenomena of refraction.
Yeah.
Okay. So I think this part is understood well. Okay. So complete the path of the red light rays. Okay. I'll show you how to do the first one. So the A line is entering, both of you unmute yourselves. That A incident ray is entering the prism, glass prism, changing the medium. So it is going to move away from the normal or towards the normal?
Towards the normal.
Towards the normal, and then after coming out, it's
away from the normal.
Away from the normal. Now you have to tell me what will happen in the second one. So Shamik, you will annotate on my screen.
How would you know if you don't know which is denser and which is rarer?
So what is outside is always rarer because that's air. And then there's a transparent object.
Correct.
I didn't understand. What have you made?
Okay, that's the light ray.
Huh?
That's the light ray.
ऐसे? इतना?
Is it supposed to, because of the surface of the prism, isn't it supposed to bend more?
So first, I want you to make the normal. Whenever you're making this, always make the normal.
Why is it bend backwards?
Huh?
Why did it bend the other way?
So just see, we'll draw the normal first. To understand it, we have to draw the normal. So your normal has to be a 90 degree on this. Right? So 90 degree would mean something like this. Right?
Yeah.
Right? Okay. Same way here also. A 90 degree would be something like this. Right? Now measure from that. This is your incident angle, rarer to a denser medium. So away or towards?
Away from where?
This is rarer, denser,
towards
then denser, rarer. Okay. So this is moving towards the normal.
Towards and then away.
And then it is towards, and then it is away from the normal. Right?
Yeah.
Right, Trisha, got this one?
Yeah.
So you will never do these questions without making the normal. And the normal, अगर कोई मेरा surface ऐसा है तो normal will be straight line. But if the surface is at an angle, then I have to make the normal based on that. Okay? Never do these questions without knowing you will make a mistake if you do not draw your normal. Okay?
Yeah.
Chalo, Trisha batao, the C one.
Will be like you draw a normal line.
I will draw a normal. Can you draw it for me or should I draw?
I won't be able to draw it. So
Okay.
yeah, like that.
So I'll draw the two normals.
So it'll first go like exactly straight.
It'll first go exactly straight. Okay.
Auntie, I'll just come back.
Then it'll go down.
So this is rarer, denser. So it's moving towards the normal. And then you're saying it'll go out like this?
Yeah.
Away from the normal. Let's check if your answer is correct. Absolutely correct. Got the idea?
Yeah.
Can we draw it without a normal?
No.
Okay. Now, D, E, F are a mixture of the first and second diagram. Do it with your notebook. The last one, you will do it in your notebook. Do it properly with a scale. D, E, F together. And share it on the group. What you've drawn. Shamik, आपका diagram ना group में share करना. अपने personally.
क्या करना है?
Make the ray diagram for this. D, E, F. Same thing. Completing the path. Done?
For E, the ray is coming right on the incident ray, so would there be no refraction?
For what?
For E,
Hmm?
it's right where the normal line is.
Absolutely, yes. Then how it should behave?
It will just go straight through.
Absolutely, very good. Shami, kitna ganda. What is this?
Pen se I was
Kyun?
making wobbly lines. So I
Kyun?
actually-
Properly banao. I will not let you go. Do it properly. This is not. Tisha, is this what you're getting?
Yeah.